Okay. Okay, let me just explain this before I stop for a short break. So this factor rating method is very simple. We don't have to what do you call it's very straightforward. Okay, it's a very straightforward. Just we think it very simply. Okay, it is popular because a wide variety of factors can be included in analysis. So it depends on whether it's a country level, whether it's a region level, or whether it's a site level. So the first thing you need to do is develop a list of relevant factors, which we have seen just now, the key success factors, okay, or the critical success factors, CSF. You can call it as CSF also. You assign a weight. This you need to do a little bit of some judgment and also some manipulation. You need to make some evaluation on assigning a weight for each factor. So if you think that a factor is more important, then you give high weights, but the total weights must be one. Basically, you cannot have more than one weights. Okay, for example, the idea is this: if the political risk is highest, then you can this 50%, for example. So 0.5, you give a 0.5 weight. Okay, and then you develop a scale for each factor, and you score each location, and you multiply the score by the weights for each factor, for each location. And of course, you're going to conclude by making a recommendation based on the highest point score. Okay. So this is a general step, very straightforward. For example, this is trying to make decision between France and Denmark about, okay, let's see. So the question is this. France and Denmark, okay? And it is a country level, because you look at that, it's country level, France and Denmark. And so this has decided to expand overseas of its first park. This theme park. For example, Disneyland wants to expand to, they want to set up a new theme park. I wanted to put in Denmark. I want to put in France. Okay, so they use this the so-called key success factors. Okay, assume that these are those importance that they have already considered. This is what I said just now. The weights. The weights mean, for example, now if you look at it, of course, very detailed, 0.39, 0.21, but they have a method of coming up with it. But if you don't want to be this accurate, you can just use one decimal place. Okay, this is 0.4, 0.2, 0.1, 0.05, 0.25. Anyway, this is the most important, followed by this. This. You understand? 39, 325, 21, 0.1, 0.05. So weights are given for each of the factor. It must total 1. It must total 1. And score is given by experts. Okay, someone who actually knows about that particular both countries and can make the scoring. Okay, they say that France is 70, Denmark is 60. So it's very straightforward. What you do is just multiply by the score for each factor. For example, 70 times 0.25, you get 17.5. 50 times 0.5, you get 2.5, and so on. And you give the total. So this is total for France. This is the total for Denmark. So the decision is this, based on the highest. Okay. So since the highest is 70.4 is greater than 68, obviously, then France is selected in terms of this. This is just a simple example. I would say if it is a real life, I would assume that you have at least probably 20 factors down here. So more than this, okay? So more than this, and of course the weight will be more than, you will need to be really detailed on this. But if you don't have the weights, you still can do the scoring and just give the total. it doesn't, it is important to put the weight, right? But it is not a must. You must have the weight. Okay, it is important, but it is not a must. If you think that the weights are equal, the thing is this: if you put no weight, that means all are equal. You assume that all the factors are going to be equally treated. Okay, that's the difference. Okay, so this is the so-called factor rating method, which can be used. Very simple, very straightforward. Nothing fancy. Nothing. It's just only the difficult thing is probably to come up with the weights and also the factors. And our class today. Okay, this is the locational volume analysis. It's a very, I'm not going to spend too much time on this. I'm just going to explain to you briefly, okay? So it's an economic comparison of location alternatives. So you need to follow these 3 steps: find the fixed and variable costs, and then plot the cost for each location, and then select the location with lowest cost for expected volume. Similar to break-even analysis, even though it's called locational volume analysis. So what it does is actually, you need the variable cost, fixed cost for all the locations. For example, in this case, we have a product and it is selling at 120, and you expect volume of 2,000 units. So with a volume of 2,000 units, we want to know which is actually the cheapest place. Basically, you can just use the formula: total cost is fixed cost plus volume, variable cost times volume. Okay, so these 3 locations, because of the location, it has different fixed costs and as well as the variable costs. If we produce at 2,000, then our total cost for Athens would be 1,800, Brussels 150,000, and also Lisbon 150,000. Just multiply out, okay? Which is a fixed cost plus variable cost times volume, okay? Expected volume. So we need a revenue line actually. But before that, we call this as crossover point or break even. Same thing, break even. So we can find the break even between Athens and Brussels by solving the simultaneous equation. So if we equate the total cost for Athens to Brussels, so you can see total cost of Athens is actually 30,000 plus 75 times X. So if we equate that, we find that the crossover point is 1,000 units. That means if I make 1,000 units, okay, it is what they call, both will actually break even. Okay, we can use a graph after this. Okay, just to tell you, to show you the calculation first. So for Brussels and Lisbon, the crossover is 2,500, which is the volume in which total cost equals between those 2 locations. Okay, and we can also graphically plot the cost curve for all the what they call locations. The green one is Athens cost curve. Okay, so this is the fixed cost, and this is the total cost depending on the volume. Okay, depending on the volume. So this is Athens, and this is Brussels. The blue one is Brussels, another location, and Lisbon is here, Lisbon. So when we did this crossover, so Athens and Brussels 1,000, Brussels and Lisbon. So this is where we show it. So 1,000 is the break even between Athens and Brussels, meaning that below 1,000, Athens is cheaper. Athens is the lowest cost when the volume is between, not 0, between 1 to 1,000. But of course, 1,000 is both is equal. More than 1,000 to 2,500, Brussels is cheaper. So Brussels is the lowest cost. Beyond 2,500, Lisbon is the cheapest. Okay, so this is locational cost volume or locational break-even. Basically, it's the same thing as break-even analysis that we have done last week. Okay, if you remember last week, of course there is revenue line and cost line, but it's same concept. Same concept. 3 locations, and you can determine the cheapest, okay, cheapest annual cost. Right? Any questions? Clear, right? This is very simple, straightforward. And another method is the center of gravity method. Okay, what does it mean by center of gravity? What is the meaning of center of gravity? Have you heard of center of gravity before? It is it's a scientific concept of, gravity is G, pulls us to the earth. Okay, gravity. So when you make a car, okay, there is a center of gravity that will actually center. If not, it will topple, or yourself. There is center. We balance all the weights and all the movements. Okay, center of gravity. So we want to find the location of distribution center, or for that matter, any facilities. Okay, location for any facilities that minimize the distribution cost. Okay, so they will minimize the distribution cost. So this problem is only considering location of markets or location in which you're going to service the customers, and it depends on the volume of goods shipped to that market. Okay, or being serviced, basically being serviced, and you only consider the shipping costs or the transportation costs, which is actually depending on the distance that the goods need to be shipped out. Okay, need to travel. So like this, if you want to locate a warehouse, you're going to serve a few regions. For example, I want to locate a warehouse to serve, for example, Tokyo, Nagoya, and I don't know, Yokohama. So where is the center? So basically center so that I can distribute, and depends on the distance. It's like this. There is no graph. Sorry. So I want to know from this location that I have existing markets. So this aspect, where should I put the center that will actually minimize the so-called shipping costs. Okay, shipping costs. And the assumption is very simplistic. Okay, very simplistic, because it makes the assumption that it only move on the grid origin. Okay, place existing location on a coordinate grid. So it is actually a coordinate. Okay, coordinate. So existing facilities is here, for example. So I want to find the new facilities that will minimize the total cost. For example, if the facilities is here, they will minimize the movement from here to here, from here to here, from here to here. Okay, so right there is the center that you are going to determine. Basically, the grid origin and scale is arbitrary. It doesn't matter, but you must maintain a relative distance. That means that's why it is grid. Grid. And you calculate X and Y coordinates for center of gravity. That means the movement at X and the movement of X and movement of Y is going to be calculated. So you want to calculate the so-called center, basically. And you assume cost is directly proportional to distance and volume shipped. That means if you move one distance, okay, you just assume it is 1 unit of money or dollar or cost. Okay, so if you move 2 grid, 2 boxes is 2 times. If you move 3 times. So it is proportional. It is proportional. Proportional means it is Paruka, proportional. Proportional, it is directly linearly related to distance and volume. So you use this basic formula, x coordinate of the center, that means the new location, x and y is the coordinate of the new location, center of gravity is the sum of x coordinate of location I, all the dix, okay, x coordinate, and diy is actually the coordinate for y, and quantity of goods move to or from location I. So qi is actually the quantity of goods moved to or from location I. But it's linear. It's very, it's just 1 times 1,000 plus 2 times 2,000. It's not. This is it's a very simplistic view. Very, very simple. It's not. It's not. There is no integration. There is no. There is no multiplication and so on. Okay. It's just adding. This is sum. Sum. This is the sum of dix times qi. Okay, let's look at example. Look at example, then we can probably understand this. So you have a store location. This is a discount department store. Okay, for example, Uniqlo. You have Uniqlo. Uniqlo, there is in one. Where I want to put the warehouse, for example. I need a warehouse. I'm going to serve this location, for example. Okay. So the number of containers shipped per month is this volume from Chicago. So you're going to Chicago to the new warehouse or the new location is 2,000 per month. Okay. So the next location is 1,000. The next one is, these are existing markets that you are serving, existing markets that you are trying to what do you call, deliver. Okay, 1,000, 2,000. Then, so because these cities exist already, and you can put it on grid. Okay, you can put it on grid. So you can put it, for example, this Atlanta is on grid 60/40. This is Chicago grid 30/120, 30/120. Okay, this is north south. This is east west. Of course, you have X, Y. So these are on grids, location wise. Okay, this is 130 at and 130. So 130, 130, 20, 110. Okay. This is the arbitrary origin, it can be anywhere. Then only you find the x coordinate for the new location, for the center of gravity. Okay, so the x coordinate for the new location is going to be for the first one. Okay, 30 multiplied by 2,000. Let's see, where's 30 coming from? Dix. Dix is 30. Okay. Yeah, 30. 30 times 2,000. Okay. Chicago is 30 because 30 times 2,000. And then plus the second one is 60 times 1,000. Correct. Atlanta is what? Atlanta is 2,000. Sorry, 2,000. So what you do is you find the X location for this Chicago. You multiply by the shipment. Okay. X location for Pittsburgh, you times by 1,000. X location for New York, you multiply by 1,000. And then X location for Atlanta, multiply by 2,000. So all the X location multiply by the weights, not the weights, the volume. The volume. Then you get your divided by your total total volume here. So 30 times 2000 plus 90 times 1000. Okay, straightforward. It's just X multiplied the respective volume. So you will get 66.7. That means X, to balance the load, X should be at 66.7. To balance the load, okay, to balance the movement. That means from 30 you need 2000, from 90 you need 1000. So you are going to get 66.7. Y coordinate is 93.3. So you will see here that, so this is the location in which it will minimize the total flow. So this is the so-called center of gravity. That means it's the center for everything. Center for everything, because one thing is they have x coordinate. But the x coordinate, for example, I need to move 2000 here. So if I add all this, for example, from X move here, from X move here, and then X, this is very little, 60 to 66.7, very little. Okay, so add up, that will become plus the Y movement, that means 40 multiplied by, what do you call this distance here, okay? So basically it's the center of gravity. Any questions? I know it's a bit difficult to understand. First for people who are first time trying to get the concept. Okay, the concept is center of gravity. That's all. Any questions? I let you. Any questions? But you, yes. I think you can. Yes, Yuma.
So, if we find center of gravity, what to do next?
So because the question is, where is new warehouse, for example, should be located? So the answer is there. This is where we are going to locate the new location for our new facility that will serve this current 4 markets. So this is a location to determine where you should put it. So the place is at the center of gravity. The location is 66.7, 93.3. Understand?
Thank you so much.
Okay, welcome. So because the initial question is, where is the new location? So the answer is at this new center of gravity. There are many other different methods. I'm not going to cover this, but there are transportation methods. There are linear programming problems that will consider other costs. Okay, so right, and finally, service location strategy. Service is a bit more difficult because service, if you put in the wrong area, purchasing power of customer, drawing area, so these are strategies that can be considered. Competition in the area. You need a new, for example, shop that sells, for example, or you need a petrol station, pump station, all pump stations. So you need to actually know the customer drawing area, many customers. And then service and image compatibility with the demographics of the customer drawing area, whether it is high end, low end, middle end, okay? Demographics. Competition, quality of the competition, uniqueness of the firms, physical qualities, operating policies, quality of management. And these are the things that is considered with difference between goods and services. Goods and services location. In service, the volume and revenue depends on the drawing area, the purchasing power, the advertising, the physical quality, parking access. McDonald's want to set up a new restaurants in a area. Some McDonald's are stand alone by itself. Okay, some are between shops. Okay, and other things. So you can compare this. You can compare between the differences between location strategies of service as well as goods producing or products, basically products. And if you look here, if you notice, this is revenue focus. If this is cost focus, then you have to think about how to minimize your cost of operations. Because high cost operations will not make you competitive. At the end of the day, if the location result into higher costs, operating costs, you're not going to be competitive. You will lose business, okay? And there are techniques that are available, okay? How hotel chains select sites? They use a regression model. Some of you probably have done regression, okay? Regression model, regression, statistical regression to predict profitability. So R-squared 0.51, from 51% of profitability is predicted by using these four variables: price of median income level, state population, location of nearby colleges. This is in US, okay? So you can also use a regression model to actually decide on location. Okay. And today, I mentioned earlier, we have a lot of tools today. One most important tool is the Geographic Information Systems, which actually have data, have a lot of detail. Today, we can even go to look at the street map, street view. Street view, I can go to Tokyo now and see the street view. So available data on detailed maps today. Utilities. Today, people map utilities also, underground, and geographic features. So this is an example of GIS. Of course, it's already more advanced than this today. Okay, more advanced, and you can see, you can fly in, there is a Google Earth.